When we look at this meteor question and we see that the velocity initially is 650 times 4 plus 2 times the exponential function to a negative power, you might think it's going through the atmosphere, the friction of the atmosphere is going to slow it down. And in actual fact, that is what part A asks. Is the speed increasing or decreasing? Often the initial speed is just nice to know. So the initial velocity, if you put in 0 for t, anything to the power 0 is 1, 2 times 1 is 2. So it's going to be 4 plus 2, which is 6. So that's how we get 650 times 6 is 3,900 metres per second. Then, to consider if it's an increasing or decreasing function, if you consider it as t approaches infinity, and so 650 times 4 plus 2 times 1 over e to the infinity. Well, 1 over e to the infinity is approaching 0, so 2 times 0 is 0. So this shows the velocity is decreasing because we've added on less than it was travelling initially. So as this part of the function is getting smaller, we're adding on a smaller amount, therefore the whole function is decreasing. So in looking at part B, when it was first cited, we actually worked that out already just to understand the situation. So now we've got to calculate after 2 minutes, and just notice that this velocity is given in metres per second. So we must calculate in seconds. So we find the velocity in 120 seconds and put it into the formula. And as we put it into the formula, we're going to put in 120 instead of t. So minus 0.1 times 120, the power is still negative, and it'll be 12. Now you could do 1 over e to the 12 or 2 over e to the 12, but on the calculator it's easy enough to put a negative power in and find out the velocity. So that calculation after 120 seconds is slower than the initial of 3,900 metres per second. So that also confirms part B. How long will it take for the meteor speed to reach 3,000 metres per second? So we put that into the formula. 3,000 metres per second is known. The formula is 650 4 times plus 2 times e to the minus 0.1 t. So let's simplify this equation. So once we simplify it to e to the minus 0.1 t equals 200, if we take the natural log of both sides, ln of e to the minus 0.1 t is just minus 0.1 t, and ln of 200. So it will be minus 0.1 t equals ln 200. T equals 10 times minus t equals 10 times ln 200. And then if we just calculate that, and there's something wrong with my answer. So rather than starting the recording again, let's just have a look. I have made a mistake. That answer is not right. If back here, when I multiplied by 650, I multiplied the 4 by 650, but I did not multiply the 2 by 650. So this is where the error begins. So I'm just adjusting my working. If I multiply both the 2 by 650, I get 1300. So then I've taken 2600 from 3000 and I get 400. So 1300 e to the minus 0.1 t equals 400. Then if I divide both sides by 1300, I get 400 divided by 1300, which is 4/13. So take the natural log of both sides. So I'll get minus 0.1 t equals natural log of 4/13, which I'm just about to put into my calculator, and hopefully we get the right answer this time. So just going back here, so I had minus 0.1 t equals ln 4/13. Minus t is 10 ln 4/13. So minus 11.78, and so the time is 11.8 seconds.